kind of going to be talking about iOS development, certification, and distribution with Unity, but it's kind of like a broad kind of general overview of these things, touching into a few kind of Unity basic stuff. So, judging by what people are saying then, there's a few people who aren't too familiar with Unity, have a basic kind of understanding of what it does, and maybe want to kind of get into a bit more detail. And there's others who know quite a lot. So, this kind of part of it is also kind of a post-mortem on a project that I worked at before I joined Unity. So it's not all going to be kind of this is how you do certain stuff in Unity. It's kind of be saying, hey, look, you know, I was a developer using Unity. We try to do something. Loads of stuff went wrong, and these are the kind of ways that we try to approach fixing. So it's more of me as a full developer rather than the Unity kind of employee. So this is get back to Unity HQ. Is okay for my previous employer.
I'm recording this process.
Sorry? No, that'll be fine. So, I mean, I like to take a general kind of personal approach to these things, because then it's a better understanding rather than me just saying, hey, these are the bullet points. Let's go over bits. So, this is kind of my recent background. Unity in the top left. I taught at London South Bank University, teaching Unity to degree students who are doing game design and game development. One of those general kind of game design courses where they just learn how to do everything and then they've got to make their own game. So some of them hadn't done any programming ever in their lives, and other people were just kind of character artists but wanted to make their own games. So it was a really cool class. So I was teaching them Unity and things, different ways that they can approach it. It's a great tool to have those kind of transferable skills. So if you do go into industry, you can have a good understanding of kind of workflows and pipelines and stuff. So I was doing that for a couple of years. I also set up the London Unity 3D user group, which I did with a friend of mine, Jasper, and that's been going for a year this month. Having a 12-month anniversary, which is pretty cool. So I've been following on from the success of the Boston user group and what you guys are doing here. So we decided to do one in London, kind of do them once a month, which is a bit different from kind of bi-monthly, which have to go out all the other user groups. But you know, we have about 60, 70 people each month. Cool. We're going to now join Unity. We can give away them Friday for our first 2 anniversaries. And then previously to joining Unity, I was also a developer at PLA Studios, which is a startup studio in London. The project that I'm going to mostly be talking about today is a project that I worked on there as a designer and lead developer. There's only a few of us in the team, so it was a really good opportunity to have hands-on development time. And this is the game. It's called Super Spring Break Speedboat Hero SD Beta. Intentionally long and stupid title that I spent many weeks trying to say without stuttering over all the S's. We did used to have like 77 at the end of it as well, and it had a 70s theme to it as well. It was just too much, so we took that out. So this is what I'm going to be talking about. I'm guessing that no one's ever heard of this.
I heard it.
Did you?
Yeah, I did that last week.
Oh, really? That's for all those kids came. Do you like it? Do you like it?
Yes.
And when was that? Today.
Sometime in the fall.
Oh, okay.
Like, we needed examples of like
Good games.
like racing games. Well, yeah. Racing games.
Okay. Oh, that's good. That's nice. So, as a quick overview before I actually show you, it was a game we developed initially for the web. It was kind of like our first project as a new team to just jump into and kind of get an understanding of how we like to operate. It's kind of some of the main features. Asynchronous multiplayer, share it via social networks, and it was roughly about 3 months development time on that one. I'm going to just jump in and kind of show you this game very quickly so you get an idea of it. So we go. Obviously, Spring Break. This is our idea of Spring Break based on American Pie or something. Dinosaurs. So you can go in and you can build your own tracks, which have dinosaurs and sharks and stuff. It's a simple track editor. And you generally race around and set time. The cool thing about this is that we were trying to do is terrible at this game. That's embarrassing. It's a defeat the point I'm trying to get onto as well. So yeah, you'd race around these tracks that you built, I know there's kind of lots of character to it, and little people on the side that you can knock over. But for a web game, we were pretty pleased. We thought it looked cool as a Unity game. And I'll give you a little time. And then if you notice in the top right-hand corner, you've got this little link, and then this is open through to the browser then, so it gives you the link in the browser. It's one of the issues that we had is inside of Unity, you can't really copy and paste text. You can copy it, you can highlight it, you can't really copy it, you can't write it. So we decided to punch it through to the actual web browser, so you can go through here and you just click this drag button, which will copy it, and then also punch it through to social networks and stuff as well. And then if you were to send this link to a friend of yours or a work colleague, what they'd get is the track that you built and then your Ghost data as well. Nice little thing we worked out when we were building this game is that apparently Polyphony Digital have got a trademark on having Ghost used as a tool to represent the replaying of someone's performance around the track. So Ghost. There we go, this is me then racing around. Oh yeah. So there's a few things you might notice in there. We've got like this quality button, so that if you were to run it on a really low spec machine, it would quality down and change the draw distance and remove certain features and stuff like that. And we were really proud of that because it meant that you can run on any machine. But the real reason was because it was really badly optimized, and we couldn't get it to run on low efficiency machines. So the way we decided to optimize it was just take stuff out. And that's the kind of thing I want to move on today, is kind of the challenges that we had in creating a game for web and then shoehorning it into iOS devices where we can't get away with having quality settings. It doesn't make sense. So yeah, not many people played it, but apparently you guys did. Pretty good. Prior to making this, we did a game for Blink-182 to promote their album, Get 182, which is another counter, and it was called Counter 182. And it was featured on Radio 1 in the UK, and it had 8 million plays. And then we put this up, and loads of people going to play this, and it came up to like 54,000. We were hoping to build something off the back of that, which was a shame. But we were pleased with the sharing features and getting around it. So after a couple of weeks of looking at the stats and doing prototypes and stuff, thinking, well, what should we do with this? We invested some time in it. We decided to ask ourselves this question. We were like, well, it should run on iOS. Like, Unity, that's what the point is that you can do cross-platform stuff and not really have to worry about doing anything extra or having a complete separate build. We should be able to compile and it should run on iOS. So we looked at that stuff and we kind of looked at the headaches that we might have in actual development, and then these are the things that we kind of came up with. So we didn't have much attention to optimization, no single player content, and no experience of iOS development. But even so, we were still confident we could actually put it together. So I mean, things like single player content are more of a design challenge. No iOS experience, obviously things that we didn't really know that went wrong or what was going on. And that's one of the things that we bumped into quite quickly. So we switched platforms, and then we clicked build and run, and then did it run? It didn't run at all. Nothing happened. And this is the first thing that we came to is that it wouldn't run, and then I was talking to the real programmer in our team, because my background in programming is good at Unity stuff. I didn't do any programming until I started using Unity, and I had a project which I wanted to build, so I was lucky enough I could say, hey, I want to do this, and I want to do this, and have a fairly logical mind, so I can put it together in my head as kind of separate processes and work out the programming behind them. So that's how I got into it. But then we had a list of errors, and it basically came down to the real programmer just saying, oh yeah, it's because they're dynamically typed and they should be statically typed variables. And I was like, okay, sure. That sounds interesting. Don't know what that means. I honestly thought it would be the way I was using the keyboard, but no, apparently it wasn't. And this is basically what it came down to. It was me being really lazy and forgetting to put things like this in. So I'm sure people understand this stuff, dynamically typed variables. this just iOS?
It's not on Android.
It's not on Android,
No, it's
okay, it's just an iOS issue, it's the way it's kind of recompiled.
When you compile it, it cycles out anything that's not used, so because it's dynamically generated, none of it's compiled into the actual application, so when you try to run any ahead of time stuff, it yeah, Java, and Java doesn't have that problem because that's how Java's built, so it's not an issue in Android.
Actually, have you done Android development with Unity?
No, I've actually never used Unity. I do everything in Mono.
I was wondering actually if it didn't just run a mono runtime on Android, since there's no stipulation on native code. It might not even make it to Java at that point. It might just be running like a
Yeah, they have their own JIT compiler, so it's not that big of a deal on Android.
Gotcha.
So we're doing the London one. Someone will ask a question. I'll just go, does anyone know? It's usually when I don't know. Some people seem really keen to do this. But that's the point I'm coming to. I wasn't a real programmer, so I didn't really understand what these things were. So yeah, we went through and we did all this. We fixed dynamically typed variables and such, and then we clicked the compile again. So did it run on iOS? So all these errors were fixed, and the reason which it wouldn't, did it run on iOS? Yes, it ran, which is great. So we were really pleased that it ran. It ran really well. No, it ran over 5 frames a second. And this is purely coming down to the optimization. The way that we originally developed the game is that we were just coming up with ideas of things that should be in the game, and we would throw them in there. And that comes from the art side of things, kind of feature side of things as well, but mainly from the art side of things. So if you're looking at the environment stuff, there's lots of kind of unique objects in there, things like crowd and stuff, and the way that we would do it, so aspects of the crowd, which on kind of first thought of how to do them, would kind of normally just be kind of, here's the crowd object, and you assume have a certain type of texture or something, and that's how kind of people. Then when we really went in to look at how these things should be optimized, we came up with different techniques. So I call it the William Shatner approach, basically. And it's just when you try and shove as much shit as possible into that shit, it's just going to scratch and bite. Like season 4, it's just going to have a very but yeah, basically, one that shit's going to rip. Even if that makes sense, the William Shatner approach. So we had lots of draw calls. Draw calls are basically things which are being pushed through some renderer, kind of mesh and material textures, draw calls. So on older iOS devices, you have a limit to how many draw calls you can push through, and the reason it ran on the iPad 2 is that it had, you could do more stuff. You push more shit into it, it would be fine. It would be a large instead of small in terms of shared size. So we had to look at draw calls, and we had to use limited memory as well. It kind of crashes over one race. Because the way we're doing all our menus and stuff, we're having issues there. So yeah. Problems in terms of actual optimization problems that were caused by design is one of the things that we had the track builder. So kind of anything that happened, like we weren't really sure how to approach it, how to make sure that whatever people did it would still be kind of optimized, it would still work. So in terms of creating track pieces, track tiles, we couldn't just create one track match. So tile or something, we import it because it could be anything. So each individual tile is kind of a separate object that we instantiate. So working out the best ways to do textures on one side of things. We had things like the viewpoint as well, which is very low down and a long kind of draw distance basically. So we had lots of objects which needed to be rendered to kind of keep the atmosphere that we were trying to go for, that was part of the design. And things like crowd objects as well, which they were repetitive, but they still had to be interactive. You still had to be able to run into this. So when it comes to optimizing the environment, batching is a standard one. Batching anything that has the same mesh in Unity and anything that has the same material texture as well. They can be batched into one draw, so the renderer can only have to deal with a single group of objects rather than each individual one. And that's kind of the standard thing which is applied normally. Combining objects was the other main thing. So if we look at this screenshot, each individual thing that you can see there is pretty much an individual thing. So down to the point where our artist was being really bad, and each individual eye was a separate mesh, and the teeth were separate meshes, and then on the King Kong, his toes were separate meshes. It was just really bad art. So I think the Kong object was maybe 20 odd meshes. The way that they're animated. People who are working team probably like this, might have too much information. But then in terms of like dunes as well, this is the thing I was going back to, is that each individual dune and each individual object. So what we were doing there is that after you create a truck, you could run scripts which are actually batched run times. So they will one mesh, basically, so turning off all the randoms for each bit of one mesh. What that meant that we could do is we could actually look into combining all of our textures as well. And that was kind of the biggest thing. So everything that you saw in that, which had like separate textures, which is in the book, we combine into this. We had two textures basically in our entire game. And that was nice because we had problems caused by design, and we had fixes which were also caused by design. We had a very minimalist art style. So we went ahead and did something like this using texture sheets. And this is just a standard thing to do. But my point is, in terms of like this optimization stuff, is that optimization should never be something that you go back to at the end of the project. It's something which you should approach from the start. And our William Shatner approach to just shoving stuff into the game. Yeah, creating a game is an iterative process. You do kind of add features in, but you should always look at incorporating those into the things that you've already got, rather than just putting them on top. So when it comes to doing texture sheets and stuff, something we should have done at the start, and not kind of as we're moving over to a different project. So when it comes to using texture sheets, the thing you've got to do there then is work out how you'd actually use them. So if you're familiar with kind of materials and stuff inside the Meetup, you can basically have like offsets and scaling. So for the texture on the back, you can set the quarter scaling, and you change the offsetting, so you're only using one particular part of the texture.
How large of a texture sheet do you have for the iOS?
It depends on kind of memory really, and the actual size of that texture. And
Depends if you're targeting 3G phones or higher. If you're just like targeting the 3G was 1024 with 1024, and then when they moved it up to 2096 with 1096, when you start running into iOS version issues too.
yeah, you mean resolution size?
Yeah, because I mean we have two different sheets, so then it's combined into one sheet.
You could, and I think you get an issue then with progression and texture degradation in terms of quality and look of the game. And then that can also depend on the actual device you're pushing to. So you've got lower texture resolution, but you're on a lower resolution device, it doesn't matter too much. It's somewhat dependent on what we're aiming for. Because we had very simplistic art style, we could use texture sheets which didn't matter too much. So yeah, we're looking at UV offset. So for something like, say like medals, which we wanted to display at the end of the game, doing an offset on that is fine, because we can have one texture, and that texture can have the gold, silver, and bronze medal. And you can just offset that, you can choose the one that you want to use. So that's good instead of having a gold, silver, and bronze texture. But when it came to doing it for something like the crowd, now the crowd is something that we kind of instantiated at runtime. That if we offset those guys, even though they had like one material on the prefab and one texture to do the offset, every time you instantiate that at runtime, you create an instance of the material. So it's basically a new material. So you're losing out on actually just trying to have one material and one texture. It doesn't work so. So, and then the other issue that you can have as well is if you change an offset on a material, all objects with that shared material, they will change as well. So if we chose to have kind of the guy with the red trunks, or for our main thing, then they would all be the guy with the red trunks. So we had an issue there, and like I said, the other thing is if we instantiated them as prefabs and different offsets, then it would be an instance. So what we looked at doing is actually shifting the UVs on the mesh over, so that kind of we'd still have one material, and we would still have one texture, we'd still have one mesh, but for each individual kind of mesh that's in a scene, you can just shift the individual UVs over on it. So then you don't create an instance of a material. So we got our kind of crowd, which could be like 100 people or something, say 200 draw calls, down to one, just by doing kind of UV shift. This is the great thing about getting the UV shifting thing is that I just searched for it on forums and someone posted it on, which is kind of like another point of Unity development, the community side of things, is that anyone who's done Unity stuff, gone on Google and just kind of searched how to do something, 9 times out of 10 you'll find somebody's already done it, so hey, I've already done this. So that helps. So if you do go onto the forums, you can check for the UV shifting, and someone's written scripts to kind of edited it slightly to meet what we wanted to do. The principle is there, it's the same thing. So if you are looking at doing things, especially for doing kind of GUI stuff, and you're instantiating that at runtime, because storing all of the GUI stuff in memory on an iOS device is basically going to kill it from the off. If you're doing UV offsetting on things to get particular parts of your texture map to show particular values, you might notice that if you go in, you will be getting instances of those materials as you're creating your menu, depending on how you handle it. So double check that. Because we had a few guys at the IGDA Vienna event who came in and they said, hey, we're still getting like 40 odd draw calls and all I've got is my main menu on the screen and it's just one texture. And we said, hey, look, go into your, when you load it up, go into your scene and look at it, and that material will be an instance of your original material. So he used the UV offsetting and then it fixed it. So in terms of UV shifting, this is basically the crux of it. One texture sheet, one material, one texture, multiple appearances. And that was really, really, really helpful. Are there any questions at this point, just in general, thoughts on things? Okay, so happy with it? That's been asked.
What are we looking at? What are we looking at there? Like in terms of like, was that the people that you're?
Yeah, that's the people.
Okay.
To me, that's really clear.
No, I figured that much. I just wanted to make sure.
Yeah. I mean, that's
Could
the
be a
environment.
vote. It's minimal, like you know.
And then that's the people.
Why are all the men bald?
Hot guys at Wolverhampton. It's the kind of guys we see on Spring Break on the TV. Windy, creepy. Within use, everything that we did was in use. So we didn't put questions. We can go over an example of how it looks. Anyone wants to see it actually inside Unity doing the UV shifting. Good thing about the actual texture sheets, we had a complaint from a friend of ours. We didn't have any red-headed people in the game. So we fixed it here with Christina Hendricks. Let me just, we should have a... If we do a quick break, and I can probably get it up there, but show this, we can go back to some Unity examples. Not now, I'm just saying. I'll go through this first section.
Okay, cool. I realize I've got some things to give away too, so we can have people fill out.
That's cool. Yeah, no, that'd be good actually. If people have things that they want to maybe look at, and these examples, bring them up to the board. Just set up some stuff, rather than you watching me use my computer or whatever. So yeah, UV offsetting. And then there's a few other things then, just in optimization, regardless of the platform. So I did a talk on optimization at IGTA last week. And my point is that doing it as a part of your workflow rather than a kind of a 2-week oh shit, I isn't running. You need to get it to run. And optimization just isn't the last minute thing. So you should all be doing this. It's a design thing more than anything. So there's a few quick things in terms of occlusion culling. People familiar with occlusion culling, particularly in Unity? Okay. Everyone's like, no. Everyone's fine.
But no use on the side.
Okay, so where's this going? Just checking where this is going. So occlusion culling is a way of optimizing the way that the render is moved. So by default, it's partial culling, which basically culls anything that's outside of the camera's visible area. So the camera kind of has this kind of cone, basically, it's rendering cone, which is called time. So the issue that you have is that something is beyond the view of the player, but is still we look at that same thing after occlusion culling is being used, you can see we have very, very little overall, and the visual impact of the player is very, very little as well. So occlusion culling is a feature which is built into Unity. It's been there since, but it wasn't the best. Like it was okay, but it was fairly slow and it wasn't that accurate. You can kind of get things wrong. This isn't just me kind of going off the company line. And then basically we spent loads and loads of money and we rebuilt it from the ground up and we redone it. So it's a lot faster, it's a lot more accurate, it's a lot quicker in terms of actually putting it into a game. So whereas a occlusion culling kind of base would take maybe 2 hours before, it can be done in 10 minutes. Unless it's quite substantial. Basically what occlusion culling is. We go through demo stuff, I can just show you a very quick set of that as well. And these are kind of the stats just in this generic kind of test scheme. The main thing is the numbers go down, which is good. But you can see in terms of like the render time is kind of half what it was previously. This was just something to set up to test the impacts that you can have on rendering a single screen. Level of detail system as well. This has been implemented into Unity 3.5. It allows you to have up to 11 meshes, which will be used at various distances to the camera. So you have, for example, these kind of 3 pillars. You can set the distances inside of the editor, and it's all in kind of real time as well. So as you're moving the sliders for the distances, the camera will move back to visualize how far away it actually be the player to you. In terms of people who are artists, maybe video artists, optimizing your art and being able to provide art with different optimization levels. And then the developers can actually basically just drag and drop them in and adjust the sliders to show the different layers there. And this kind of helps in that on one side of things, we're trying to reduce the amount of things that the renderer has to cope with to get the game running better. And on this side of things, we're reducing the actual complexity of what it's got to do. And then final thing kind of optimization is just knowing your kind of platform limitations. It's just a general kind of broad overview of the kind of different things we're looking at. Dedicate your graphics and desktops. But you look at the differences in terms of draw calls that you can roughly get on an original iPad and the memory usage on the original iPad to the iPad 3. I mean, in such a short space of time, it's a huge, huge difference. We compare it to kind of like a console generation loops, we get kind of really short generation loops in kind of iOS tablet hardware. Things that we can do today on an iPad. For example, the first build we did of that game on the iPad is pretty okay on iPad 3.
So, I mean, if you're going to design it today, you still design it so it runs on the original iPad? Or
Yes. I mean, it's if you're trying to start, you want it to run as many things as possible. And then, depending on the game that you're trying to make, in most circumstances, there should be no real reason to why it shouldn't run on original iPad. But it'll have game that starts the game that we were making. We got to a point where we were like, oh, maybe we should just put it on the 4S and the iPad 2 will probably fine on it. But that was just a lazy decision to make. You should be looking at these things. And the best bits of advice that we can give to people is just do some tests, work out what will run on these things in terms of designing the game that you're trying to make, is work out the areas which are going to cost you most, and see how you can do those.
So basically you're saying that if you can make it run on an iPad, it should run on everything. Basically.
Essentially, yeah, I mean, if you look at an iPad and use that as a comparison to like a 3GS, 3GS is currently the last, but the oldest.
There's still a lot of 3Gs out there. Those have a really low, they don't have the shared texture memory, so they have a really low ceiling.
Yeah.
So supporting them is really challenging.
Yeah.
It also doesn't
30
support
megs.
OpenGLES 2,
Yeah.
which is a no-go for us anyway. In fact, no offense, but I would recommend skipping the 3G. They're not selling units anymore. That volume will only decrease. 3GS, on the other hand, is still on
Yeah.
sale. That
Yeah.
volume's still going up.
Yeah, that's
I don't agree with that.
in terms of backward support, that's something we're selling with 3GS.
Yeah, exactly. Basically, that's our target is anything that's on sale today, we'll publish for. And in the case of the iPad 1, it actually closely mirrors the specs of the 4th gen iPod Touch, both
Yes.
in resolution and processor.
Yeah.
So You have to hit agree.
I mean, judging what you were saying, like it's a pain in the ass to do it, but a business decision, yeah.
How about the resolution aspect? Do you have to deal with that, or is it?
Yeah, I've been doing some basic tests on that. But I'm not too sure how it works. Has anyone done any stuff on the iPad 3?
We just shipped our Retina build today,
Oh
actually.
yeah, of course.
The A5X chip, plenty of bandwidth. Doesn't matter what you throw at it, it'll just eat it up, spit it out, doesn't care. We doubled actually all the textures. We just made them twice as big for the iPad because, yeah, we'll throw 1024s at it. We'll throw 4 of them at it in one second. It doesn't matter. Ate it right up. Didn't care. It was incredible.
And I don't know if any of you picked up the news today. I think we shipped 0.51. We shipped a new version of 3.5 anyway, which now has built-in support for iPad 3 resolution, so you can go in your iOS build and select the actual correct resolution. I think the main issue is with the new resolutions trying to do the GUI stuff again. If you do the GUI efficient way, then kind of pushing it to fine resolutions. Another issue. And then a few just general tips, like if you want 60 frames a second, these are kind of the frame times, milliseconds per frame that we need to look at, just as a general kind of maths. But then that follows on to saying that if you're trying to hit a higher frame rate on something, then the performance impacts of that particular game is greater. So the higher the ceiling, the lower the ceiling you're trying to hit to the kind of bigger your thing. So in terms of optimizations, the next slide that comes on to originally stuff, the distribution on iOS. Maybe this is a good point to have a little bit of class example. Brad's got something to show.
Yeah, actually, I've got some things to give away, but I forgot to hand some things out to people to sign up. Does everybody have a business card? Or do you? Yeah. Or I could give these out, and all I need is like a name and email address would be fine.